Hello guys, and welcome back to my channel. And in this tutorial, I'm going to show you how I use the Parametric tab. If you're familiar with Inventor, you would know that the power of Inventor is that in Inventor you can use parametrics to parameters to design your whatever you're designing. And the power of parametric is that you can make your design, add some parameters, and then while if you want to change the design, or you want to not per se change the design but like change your measurements, your dimensions, you can do this and the program will automatically recalculate the distances, the sides, and whatever it is you are dimensioning in your design. So this is an example of a design I made using Parametric. So if you are interested in this video, guys, I suggest you stay tuned and I'll show you when I come back after the intro. Welcome back, guys. So now this is the design I was I was telling you about. And in this design, let's see. So oh, if I go into my parameter manager tab, I can here change the different depth, height, and other important measurements I assigned into my design. So I will show you how I did this. So first of all, let us go into a new drawing. And I already pasted this, let's see, top view of my little cabinet right here. And as you can see in this design, we don't have any parameters at all. So we're starting from scratch. So first of all, what I like to do is make sure use as much as possible geometrics. What geometric does is, like in AutoCAD, you have all these polylines and all these squares and rectangles. And what happens is, let's say if I stretch this, as you can see, it's stretched in all directions. So you want to avoid this when you are using parametrics. So how we do this is by using your geometrics. And first of all, geometrics, as I will show you a few. I won't show you how I did this all in this, implemented it in this, because this will be a very long video. But I will show you just the basics so that you may get what the different geometric does and how you can use them. So first of all, you have to make sure that this, let's say, top view is constrained. That is why they are called constraints. You don't see them right here, but they are actually called constraints. So you can then, I'm not going to auto constraint because then it will constrain everything. I would like to do them one by one to see what happens, because if you auto constraint, maybe you will have too much constraints and then you cannot use your parameters. So first of all, let us make sure that this does not happen. So when I stretch up, that this point does not stretch all directions. So to do this, first of all, we have to make sure to make everything perpendicular. And let us do a few. So perpendicular to that and perpendicular to this right here. So right here, we have already implemented two constraints. And now if I try, oh yeah, by the way, so that was perpendicular. And now, no, I'm going too fast. Let me show you what perpendicular does. And perpendicular is just that to make sure that this angle always remain 90 degrees. So if I stretch it, as you can see, it remains 90 degrees. No matter in what direction you stretch it, you cannot break the 90 degrees angle between these two lines, neither between these two lines. that is what perpendicular does. It just makes sure that your 90-degree angles remain. Hence the term constraint. It remains constraint. Now this one is the parallel constraints, and this is to avoid from two lines being not parallel to each other. So let's see, what lines do I want to be parallel. I want to make sure that this line is always parallel to this line. So now if I try and move this, even though it is moving all directions because I haven't used my perpendicular, it still remains parallel to each other. As you can see, it's still parallel to each other. So that is what the parallel line does. That is straightforward. Now, this line right here, collinear line or constraint, is to make sure that your line remains in the same line. So your two line remains in the same line. So let us use this for these two. So we had made it collinear to each other. So now if I move this one, let me see if I can move this one up or this one up. You see, it remains collinear to each other. So meaning parallel, not really parallel, but just in the same line. So since I move this line in an angle, this line also goes into an angle. So that is what the collinear does. So when you're using collinear, you have to use it, let's say, also to this line, so that this line right here, always remain connected to this line. And the same, actually you don't have to do it here again because this one is collinear to this line and this line is collinear to this line. So now if I try and move this right here, as you can see, everything moves because they are all collinear to each other. So it's like a chain reaction. Now make sure you use again your perpendicular to make sure that these lines remain at a 90-degree angle. Now this error right here you will get when these two lines are already um, perpendicular to each other. And that's because, as I said, it's like a chain reaction. So since here is already perpendicular and here is already perpendicular and this is already perpendicular, there's no need to make a fourth perpendicular because this will always be perpendicular because the other three are already perpendicular to each other. So yeah, basically it's already constrained. So if I try and move this line, as you can see, it won't change direction. As you can see, look, it won't change direction. This one is already perpendicular to here. The only thing we are missing right here is a perpendicular in my side of my cabinet. So make sure here is also perpendicular so that whenever I move this line or I move it up, it moves in the same direction. So that is step one when you are working with this. Now right here, as you can see, this one is also not working very good. So first of all, we have to make sure these two lines are 90 degrees, not the rounded off, the fillets, but just the straight lines. So make sure that all your lines are 90 degree, and this one is 90 degree, this one is 90 degree, this one is 90 degree. So automatically the fourth one we won't have to do anything to it. Now here we can collinear these two lines to each other. So these two lines will always be in the same line. Now let us do also perpendicular on this side to make sure. And these right here. And I think this one won't be needed. So as you can see, it is not needed. So here we have our handle. Now, as you can see, I can still stretch this one down. That is because the distance right here is not yet set. So it's kind of difficult to set any distances with your geometric. So let us just move it for now. And now this line right here, which is the top of my cabinet, I would like it to be collinear with this line right here. So it would always be connected to that line. And as you can see, it did what it was supposed to do. It just joined each other. Let us move this one again manually. And again, this one we also have to make a collinear to the door front. Actually, this is already collinear, so that is also not needed. And let's see what else we have to make sure is done. Oh, this also has to be collinear to the back, and here also have to be collinear to this one, or you can do this one collinear to this one, whatever you want. Now this right here, I think this one hasn't done anything as yet. As you can see, it is still moving all type of directions, so we have to make sure we use our perpendicular to make sure these lines are always 90-degree angle to each other. I think I did this one already. Okay, so that is good. Now let's stretch it again to see what else is missing. As you can see, this line also right here, this corner is not perpendicular or constrained. So we did that right there. And now let's see again. Now we're talking. So now everything is constrained according to me. Nope, still not. So that is why I stretch it to see if everything is working properly. Let us see, this one is not. Now it have many ways of doing the same thing. So whenever you are trying to constrain your geometry, like right here, as you can see, those two lines was on top of each other, so it was kind of difficult to collinear these two lines together, but now it is. And the same thing I will do for the other side to make sure it always remain in this point. Now this is the annoying part of it, because as you can see, it collineared, yes, but then this line was at an angle, so it chose this line to angle the other line. So let's go back. Okay, this line, this thing is also not working out, so this one I will have to stretch down this way and stretch this out that way. Yeah, guys, sorry, you have to play with it a little because we haven't constrained, we haven't done anything about this right here, so it's kind of loose. So sometimes better just to delete it. Now, to avoid the line from going the other direction, what we can do is use this lock right here. And what this locks is just fixes a line or a point to make sure it does not move. So now I want to lock this point right here. I want to lock this point to make sure it doesn't move that direction. And no, actually I'm gonna reverse that or delete it. To delete any constraint, you could just right click on the constraint and just press delete, and then it will remove it. And delete constraints, it will delete every constraint you have in the drawing. I will constrain this instead because the front is more important than the back, because then when you're using parameters, your parametrics, you can parameters, you can then since this is locked to the front, then it when you make it bigger and smaller, it will move in the up direction. So you have to also think about how it will respond to your uh, parametrics. So as you see, I used again the collinear, and instead of it going in an angle, it just came back this direction, meaning straight. That is because I locked these two corners right here. So that is also handy to use. So now we had this one and this one. And concentric is just basically when you have a circle, two circles. I won't be using this in my cabinet because I don't have any round objects, but I will show you what this does. And basically it just aligns the two circles within each other, the center point. So that is what that does. And now let us try again with a handle. I will use my polyline and I will just freeform or basically draw a handle without doing any kind of measurements. Just make sure it is, no, I'm not even gonna make sure that it is closed. It is still open. So I will show you what this one does when you are working with this. Now, again, we have to make sure these lines are parallel to each other. And again, we have to make sure these are perpendicular. Now again, the same thing happened again. So now again, you have to make sure your one point is locked. Let's lock this one for now. And let us do again perpendicular. Nice. The other side. Collinear with these 2 points right here, because these 2 points will always be the same height. Let us see what else we can use. Again, perpendicular. And here again, perpendicular. Let's see. Let's do this one here also. Sorry, my... Now, yeah, basically just check it by moving something and then you can see what is missing. Now, a nice other one is equal. And what equal does, it makes sure that these two lines are exactly the same size. That is, I want this to be this way, so that's why I made these two equal. What else do we have here? Vertical constraints to line up pair points to. So basically this one is just to, instead of using collinear, because collinear is for two lines, this one right here is the same as collinear, is just for points. So like I want to make sure that this point right here, let's say this one right here, no, this one does not have a point. Okay, so it's already constrained, so it's kind of difficult to do any more constraint to it. But it's basically the same as collinear, but just for points. So to make sure the points are vertical to each other with this one and horizontal to each other with this one. So let's say if I drew a line and I want to make sure this point is collinear with this point. As you can see, these 2 points are now horizontal to each other. So it will never move. It will always remain horizontal to each other. And again, the reason why when I did it just now, it did not do anything is because it's already constrained. So it already knows, like, oh no, it actually did it. As you can see here, it is horizontal. It will always remain horizontal. And let's say if I did this one right here. Okay, this one is already constrained. Let's try this one already. And let's see this one. Oh, it's mainly because these right here are already here. So you cannot do any more constraining because this one is horizontal, always will remain horizontal. So that means since this is 90 degrees, this one will always remain vertical. So it's kind of a little bit of logic behind of it, of common sense. Let's see if this one is the same thing here. So you can either, so that's what I say. There are many ways to constraints, and basically, if you do one, maybe the other won't be necessary. So it depends on what do you like to do. Now, let me just give you a next example with a circle and this right here. This is tangent. This one is called tangent, and this just makes sure that your circle always touches your line right here. So even if I move my circle does not stop touching my line. It always remains there. This is where smooth, which is just a spline, so you can make sure like smooth your spline or join your splines together. Let's see, this one is symmetric. It will make two lines symmetric to each other, so meaning um, whatever degrees the first line is, the other line will be also. Let us try it to show you examples. Let's say these two lines right here, and I go to my parametric, and right here select your first object, select your second object, and then you have to select your symmetric line. As you can see right here, they are symmetric to each other. So if I move this one up or away from the symmetric line, the other one also moves. So they will always remain the same distance from each other. Let's see what else we have. And this one right here is just to make sure 2 points always join each other. As you can see right here, I just did it. Let me see if I can do this. No. For example, this right here. So now we have to always make sure this point is touching this point, and that's the reason I didn't close it at the first time. So as you can see, you get this little blue line right there, little blue square or dot right here, or pixel. And then here you can see now that it will be always joined. So now if I try move my handle, as you can see, it's nicely constrained. Everything is moving in the right direction with each other, communicating with each other. And now I can go ahead and collinear this to my door front. And then we just move this one up. It looks a little weird. Oh, wait a minute. I know what is going on here. I think I locked this one. As you can see, this one is fixed. So now I can go ahead and delete this one so that I can move it again. So that's just a pointer. Now you say this is so annoying to have all of these constraints visible, but AutoCAD thought about that. You can just hide them all. And it's still constrained. As you can see, I can still move my cabinet and it remains constrained to each other, even though you cannot see your constraints. And as I said again, you can just delete also and it will delete all the constraints. Now let us go ahead and use now your dimensional parametrics or constraints. So now we have a few. You can you can constrain your diameter, your radius, your angles, and of course your angle um, dimension or linear dimension. It's very basic and straightforward. And then you have a dynamic constraint mood and annotational. I don't really work with annotational, but I will show you the linear, basically what you will mostly use, which is your linear. Now, before we get into that, now let's move on to the parametric manager. Now, to add parametrics, you have to create a parameter or a parametric. Sorry for my accent. I just um, speak a different language. So to create one, you have to just click on new, basically create a new parametric. And here we will call this one depth. And let us create one for your height and a next one for your width. And I also want to know the panel thickness, so I will just call this thickness. Now, these are your parametrics, and now my depth will be 600 as a starter. I want my height to also be 600. Matter of fact, let's just change the depth to 5 so you can see the difference. My thickness of my panel will be 18, and the width of my cabinet will be, let's go for 450. Now here the expression you can change, but you cannot change the value. This is just AutoCAD telling you what the value actually is. And here the expression, I will show you just now what does this means exactly. Now these are all user parametrics. That means I'm the user, so I enter these parametrics manually. So meaning these are user parametrics, so my parametrics, but there are also model parametrics, and you will see just now. Now right here, I would like, first of all, before I do this, let's just make sure that these two are equal. I can't remember I did this. So this one is equal, and this panel is also equal to the thickness of that panel. Just make sure do that. So now let's hide all my constraints again. So now let's move over to my dimensions. And here you can see it is asking for a point, first point, and no. Since right here, we locked this point right here. Let's see, where is my lock? Or this, where is it? Let's show all again, right here. Since I locked this line, as you can see, this line is locked. It will be wise to work from here. So since this one is locked, let us just add a parametric to this lock line instead of the one to the top. So here we have our first parameter, which is D1, and it is 18 millimeters. That is correct. But, well, basically you can just create it. So this one is 18 millimeters. Why it locked it is because this one is already locked. And I think this one is also locked. So it's too much locked. Let's unlock this one. Let us try this again. Make sure you get the corners right here. Now this one is D1, as I said. Enter. Why is it locking it the whole time? I just deleted. This one is deleted. And where else do I have a lock? Show all. This one is locked, correct? And where are my other locks? They are not there. That is strange because, okay, it does move. Okay, but either way, I want this to be not 18, but I want this to be equal to my thickness. So then you will go in and you will type thickness. And here we have it, our first successful parametric, which is thickness. So D1 will always be equal to thickness. And that's step one, basically. And since we already constrained, let's see, made this, so the 18 millimeter equal to this one and this one, what will happen is whenever I change the thickness to a different value, let's say, let me try this out. Let us make it 12. As you can see, this will be 12, this will be 12, and also this will be 12. So we all are tied to each other. Now let us go into making our this right here and this right here. And this is our depth. So D1 is equal to depth. Nice. Now let us go into our width of our cabinet, and it will be from corner to end corner, and this will be D3, and this I will link it to width right there. Now, as you can see, this happens, but this have a very easy solution to this problem. It is actually not a problem. It's because you have to tell AutoCAD what you want to be this distance. So now let us go into our parametric again. Now I want this to always be 2.5. And of course this side will be the same. So I will click, and then when it asks me for the value, I will then select this value. So these two will always be the same. Now the distance from my handle middle point to the end of my door will always be 50. My door handle itself will always, center to center, will always be 192. Now this happened because I haven't linked this as yet. So let us go ahead and make this a little more. Yeah, right here. And now my door handle thickness, meaning the diameter of the handle itself, will be 8 millimeters. That means that this one right here will also have to be 8 millimeters. Right here. And again, you just click on the one I already made, and it will remember that for the next time. So here you can see it is already building my dimensional constraint parameters. This is from my so to say based on my design. So these are based on my design, and these are my users. So as you can see now, since I made my users first, I can change users whatever I want here, and these will automatically recalculate, and AutoCAD will do that for you. What else do I have to do? Oh yeah, the height. Make sure the height is always the same. The height of my handle, I mean to say, let's just constrain it here. Let's make the height always stay 25. And I think that was about it, guys. So now let us hide all of these dimensions, and let us just play with this a little. So the depth, I want it to be 450. Wow, works properly. The height, we haven't used the height as yet because we don't have a front view of elevation or elevation view of our cabinet. So let's just work with the others. This one will be 12. As you can see, this is 12 now. This is also 12. This is also 12. And the width, let us see if the handle remains where it's supposed to be. Let's make this 700, and it works perfectly. So now the next step is, of course, to use your normal annotation with your normal linear dimensions. Let us make this. Make sure you use your correct dimension style. If you want to know how I made these dimension styles, you can watch my tutorial how to make a style. I will link it up above. Let us make my dimensions, or place my dimensions correctly. I want to know what's the thickness of my door. I want to also know what's the total depth, including my door. What else do I want to know? The thickness of my sides. And let us use the continuous dimension. So here I will know the thickness of my sides and the width of my panel on the inside. And here the total width of my cabinet. So let us try this again. Let us do, let us make this 15. Perfect. As you can see, this becomes 15. This one did not work properly. That is because I think the continuous line works better. So make sure you use a continuous line. You place your first one and then you continue. And it does not always work properly. I still don't know what's the trick behind of it. Like, what do I have to do exactly to make sure my lines are linked to my, I think it's reassess. Let's try this one. Or maybe this one right here. Anyways, that is always my struggle with these dimensions, to make sure that they remain associated. If you know exactly, guys, how to do this, show me in the comments below. Believe me, I don't know everything also. I know a lot, but some things I never really dive into. Maybe I will in the next video. Now let us try with the width, 600. Perfect. Again, these dimensions, I don't know why. So as you can see, the parameters are working properly. Also here you can see that my center is remains 50 at all times, and also the center of my handle also remains the same. So that was parametrics, guys. It's I thought it would have been a shorter video, but this was quite a long video. I think I will make a part two to show you how I then basically, if you use the same example I showed you in this part right here, you can then do this what I did right here. And with this one now, which is the end result, meaning here you have my side, I have my sides. As you can see, everything is linked to each other. I have my top panel, bottom panel, my back panel, my right side, and my door. And everything is linked to each other. I also have a few details right here. These are also linked to the information up above. So I will show you right here. And as you can see, the list of parameters or parameters just grew gigantically compared to the example I just did. And here, if I change my width to 450, as you can see, my depth, sorry, my depth, as you can see, everything also changes. Let's see. The only thing I did not do is, let's see, I think it was this right here. Oh yeah, I have to make sure also here you can also do a little calculation. So just make sure this is 150. As you can see, it also make these 150. And this one right here also, again, with these dimensions, they are so annoying. As you can see, it also changes automatically whenever I change the information right here. And this also you can decide to make this this is the next example I needed to give, is the difference between expressions and value. Basically, your value is the value that it is eventually. So this is your expression. So here we have expression is actually a link to other dimensions or expressions or other parameters. Like here we have depth. So here the expression is for parameter D61 that this is equal to depth. So here we can see the value of depth is 450. But here we have parameter D51 is equal to minifix distance. So right here, minifix distance, which is 8, and minifix distance plus 1. So meaning our value would not be 8, but 9 millimeters because it is 8 plus 1 millimeter. So that is basically the difference between expressions and value. So value you cannot change. The value is just a update of Inventor giving you the value of what you entered in your expression. That's basically what it is. And that is also here that we did here. As you can see, my depth from D2 is depth, and the depth is equal to 450, which is a value 450 right here. But now if I decided to say my depth is 450, but here I want my depth to be 450 minus 50. And as you can see here, then the depth of my actual design will not be 450 as the depth is, but it will be 400 because the expression is then the depth minus 50. So that is the difference between expressions and make sure it's in the corner. That's the difference between expressions and value. So expressions, again, the expression you entered, so the value you want it to be or the calculation, and the value is just AutoCAD telling you, giving you an update of what the actual value is eventually. So guys, that was it for now. I hope you liked this video. I hope you learned something valuable, and I will teach you how, or I will show you how I did this and what this is about in a next video, a part 2. And it's very handy. Oh, here you have this same problem again, but I will fix this in my next video. And I will show you how I what the idea is behind of this whole um, bunch of panels and what this means for your design. So I will see you in my next video, guys, and bye for now.